Let's solve Leetcode number 1, toSum. This is the most commonly asked coding interview question. In this question, we're given an input array and a target value. We need to find two numbers that add up to the target value. In this example, 2 plus 7 is equal to 9, and we return their indices. The index for 2 is 0 and for 7 is 1. So we return 0, 1 as the output. We know that there's exactly one solution, so we don't have to worry about finding multiple solutions or not finding a solution. So the most logical, intuitive way of solving this problem is to check any combination of the numbers to see if their sum is equal to the target value. Let me copy the example 2 over here. Let me also add their indexes. So my approach is to create two pointers. The first pointer at the first value of the array, and the second pointer, j, would be I plus 1. We check 3 plus 2. Does it equal to 6? No, it does not. So we increment j. Now we check 3 plus 4. Does it equal to 6? No, it does not. So we start over and increment the I. Once we increment the I, j would automatically increment it because j is I plus 1. So we check 2 plus 4. Does it equal to 6? Yes, it does. So we return their indices 1 and 2 as shown here. Okay, so let's code this real quick. We'll create a for loop. I equals to 0. I less than nums.length I plus plus. We create another loop with j equals to I plus 1. J is less than nums.length j plus plus. Now we check if nums at I plus nums at j equal to target. If it is equal, then we return the indexes I and j. If I run the code, we see this is a valid solution. Let me also submit this, and this is, it's a valid solution. It's working solution. It gets the job done. But if you get this question, your interviewer would ask you to come up with an algorithm that is less than O of n squared time complexity. As you can see, the solution is not very efficient. The time complexity for this solution is O of n squared. And we can do better. There is a smarter way of solving this problem. We can just do it in one loop by utilizing a HashMap. Okay, so the way that we can solve this problem by using only one loop is to iterate over each of the elements. So our loop will start here. We'll check target minus the current number. So 6 minus 3 is equal to 3. Do we have a 3 in our hash map? We don't have. So we will store its location, its index in our hash map. Then the loop goes to the second element. 6 minus 2 is 4. So we need a 4 that we can add to this current value. It would give us a target value of 6. We know that we have it in our array because we can see that, but we don't already have it in our hash map. So what I'm going to do is store the index for the 2 in our hash map. And then we move to the next element in our array, 4. So what number do I need that we can add to this current number would give us the target value? We know that target 6 minus 4 is equal to 2. So we need a 2. And since we already have 2 in our hash map, so we can return the index for the 2 and the current index for the 4, and that is our solution. All right, let's code our optimal solution. First of all, I'll create a hash map, and I can set it to an empty object. And I'll loop over each of the elements. Let I equals to 0, I less than nums.length I plus plus. Okay. Current num, because that's what we use in our example. Current num equal to nums at I, and const num to find equal to target minus current num. And then here I'll check if our hash map has num to find, and I'll add greater than or equal to 0, because we know that the arrays are 0 indexed. So here you see the index for 3 is 0, and if I don't have this check, it will fail because 0 is a falsy value. And so if there's already a value in our hash map, we return that value from our hash map along with the current index. If we don't have the value that we need, then we can add the current numbers index to our hash map. So that would be hash map current num equals to the current index. Let's run the code. As you can see, it's been accepted. Let me submit this. Working perfectly. This was our solution. Our time complexity is O of n, which is better than the O of n square, and our space complexity is also O of n due to the hash map.